This is the objective, which is also the title of the experiment, to measure the angle of a taper rod or any taper object using sine bar and slip gauges. So what are the apparatus necessary for conducting this experiment? You need a sine bar, a standard slip gauge set, a surface plate, and dial indicators. What is a sine bar? So as you can see from this figure, that this sine bar is basically a rectangular bar. It is a tool used to measure the angles of objects or components of different sizes. If you want to do their angular measurement, then this equipment or this tool is very useful. You can see this is a solid bar which is having some holes, some relief holes are there. These holes are made to reduce the weight of the sine bar. And then you have two surfaces. This is the upper surface and this is the lower surface. These are flat and parallel to each other. Then you have these cylinders of required size, and they are made to a very high depth of precision. Their axes are parallel to each other, and there is a fixed distance between them. The distance between the axes of these two rulers is the length of your sine bar. This sine bar comes in different lengths like 100 mm, 200 mm or 300 mm. Depending upon the size of the object to measure, you need to decide the length of your sine bar. This sine bar is made up of high carbon and high chromium stainless steel. What is the use of this material? You need to make it highly corrosion resistant so that its accuracy and precision will not be affected with the course of time. And as you can see, this is made very accurate and precise. The length of this sine bar is engraved somewhere here or on this side or at the back so that you can easily determine its length. It is a standard for a particular sine bar, and sine bar can also be available in different shapes. Like this, for very small specimen, this type of sine bar is available, and different manufacturers can modify the design. The requirements are that you need parallel surfaces, this surface and this surface, and then two cylindrical rollers having fixed distance. Some relief angles reduce the weight of the sine bar. These relief angles are used to locate your sine bar over the workpiece using pins. And then you have slip gauges. So these slip gauges comes in this set, and there are different companies, like this is a Mitotoyo's sine bar slip gauge set. Then another company is called Metrology. They also make this slip gauge set. And you see there that you have different types of slip gauges depending upon the thickness. In this case, it is starting from 2.12 mm, and then its thickness is increasing, and then you have finally you have a 100 mm lengthy slip gauge. This is also made up of high carbon and high chromium stainless steel, and each slip gauge has also two surfaces, this surface and this surface. Both left and right surfaces are very flat, and they are having a high degree of surface finish. Very smooth finish can be seen on this surface, just like mirror-like surface. These are slip gauges, and you need a surface plate made of cast iron or granite. This type of surface plate and all these basically sine bar, slip gauges, surface plates are available in our metrology lab, where you can conduct the experiment of your sine bar in order to measure the angle of any object. And this surface is also very flat. This top surface is taken as the reference or datum plane for any measurement in metrology. Any type of measurement you do on the surface, you try to perform your measurement on this surface plate because it is made very flat and it is also very finished surface. So errors in the measurement are minimized. Then you have this simple dial indicator. In this dial indicator, you can see there are hands. It works like a clock. It moves like this. And you have a plunger mechanism. This is your plunger. The plunger, sometimes you call it a stylus. Whenever you press this plunger on its surface, the mechanism is actuated, and then whatever be the you can say any deflection in this plunger, it will be recorded here on this dial gauge. In this case, you see that the smallest division is 0.01. Any deflection on the surface or any irregularity on the surface, and then you move this dial indicator on that surface, so that deflection or deformity is recorded with the help of a movement of this plunger or stylus. Then the same deviation can be seen on this dial gauge with the help of this needle. One rotation gives you a deflection of 1 mm. Whatever the deflection here, you can simply record that deflection and measure the dimension. So these are 4 basic apparatus or the equipments which are required to perform the experiment of sine bar and slip gauge to measure the angle of any object. Sometimes you need one magnetic clamp to hold this dial indicator. With the help of this clamp, you can slide your clamp onto this surface plate and then move it onto the surface of your object to measure any deformation and deflection. Your sine bar is used in conjunction with slip gauges for precise angular measurement. And as I have said, that this is made up of high chromium and corrosion resistant steel, hardened and ground and stabilized. You have 2 cylinders of equal dia which are attached at each end, and the axes of these cylinders are parallel to each other. The upper surface and lower surface both are parallel to each other, and the accuracy up to 0.01 mm of length of sine bar can be obtained. And how it works? So it works on the principle of trigonometry, and you measure the angle of any tapered surface using the trigonometry formula that sine theta is equal to your height and length of your sine bar. So there are 2 cases when you have to measure the unknown angle of a very heavy component or very large size component. You invert your sine bar and place that sine bar onto the surface of your component. You know this length. This is the distance between the center of these 2 side rulers. And then with the help of this vernier height gauge. So I think you have already an idea about what is a vernier caliper. So that same vernier scale or the principle of vernier measurement is used in this case of your vernier height gauge. So this is basically a gauge which is having a stand, and this is your mechanism which is having a spring loaded stylus, and then you have a dial gauge to see the minimum possible deflection. The reading of the height, this is the height which is the H2 or H1 you can consider, and similarly on the other side you measure the maximum height of this roller. This is the height, and with the help of the formula that sine theta is equal to difference in the height of this component divided by the length of this particular sine bar, you can easily measure the angle of your component. And another is the case that whenever your equipment or object to measure is of very small size, so it can easily slide beneath the surface, this surface of your sine bar. You take your surface plate and then you place your object onto the surface plate, and then with the help of the sine bar, place your sine bar onto this inclined surface with the help of slip gauges. Slip gauges, I have told you that it comes of different thickness. By stacking of these slip gauges, you can have a combination of the slip gauges, and then this combination can be slided into this gap between the roller and your surface plate, and the combination should be selected in such way that it should easily slide into this space without distorting the placement of the sine bar, without displacing the placement of the sine bar. You just simply slide the slip gauge combination under this gap. I already told you that the slip gauge is having different thicknesses engraved on its surface, and then with the help of addition of these length, you can simply know the distance. With the help of your sine formula, you have this height and you have this length. So with the help of formula, you can measure the angle. Sometimes your workpiece of very small size, so that it is difficult to place the sine bar over it. So what you do, you place your workpiece in inverted condition over this, and then slowly try to lift the sine bar with the help of the fitting of these slip gauges till the surface becomes parallel to this surface plate. And the deflection, you take one, see in this case, in this diagram, that you have your sine bar like this, and then you have your object which is placed over this top surface, and from one end then you need a dial gauge, dial indicator. So what you do, from one edge to another, you try to move this, displace this dial indicator and see the, so based upon that deflection, you continue to add up the slip gauges in between this gap and try to increase its level till it becomes horizontal. Then you continuously check the deflection in the dial indicator. You have to continue to add your slip gauges till there is no deflection in the dial indicator, which means you have attained the required angle in your arrangement. Combination of the slip gauges gives you the height. From the simple formula of sine theta, you can easily measure the angle. Okay. And very important point to see that your slip gauges should be arranged in this particular step. So this is the process of stacking of your slip gauges, and this particular step is known as the ringing of your slip gauges. So just what you do, you take two slip gauges and then you place them like this, and then with the help of very less vertical pressure, you try to press this surface, this bottom surface, onto the flat surface of this bottom slip gauges, and then you try to slide it like this until you reach the middle. Then you try in the press position, you try to rotate this slip gauge in order to make them parallel. This is the method by which you arrange all the slip gauges onto each other. This is the first slip gauge. Suppose if you required more slip gauges to your combination, then you repeat the same process like this, and this is called the ringing of the slip gauges. Both this surface, or you can say the lower surface and this surface, all are flat and having a high degree of surface finish. You have a very high contact area during the sliding motion, and during the small vertical pressure, what will happen, the asperities on this surface or on this surface, they are plastically deformed. Observed sort of cold welding between the asperities, which is very much required for minimizing the error in the combination of your slip gauges. What will happen if you simply place your slip gauges over it, the gap between them will have air gap, and then this will cause the error in the measurement. While selecting this slip gauge combination, you have to take care of this fact that you need minimum number of slip gauges in order to minimize the error in your measurements. How the error is coming here? Error is coming here due to the smallest possible gap between the slip gauges. And for that purpose, this ringing process or this particular procedure is very helpful in minimizing the gap between the slip gauges. So this is the procedure that how you perform the angular measurement. You have two conditions: when there is a very big component and it is very difficult to place your slip gauges, to place that component in between this slip gauge in below this surface. So what you do, you invert your sine bar and then you do the measurements with the help of vernier height gauges. And you have another cases when you have very small whenever you have a comparable, then you can do your procedure like this. And in case of very small specimen, you can place your specimen onto this surface, and then you follow this procedure to get the surface parallel to the surface plate. With the help of this dial indicator, you will move this dial indicator continuously till you receive no deflection on your dial indicator. And with the help of this height gauge, slip gauge combination and this length, which you already know, you can easily calculate the angle of this particular tapered surface. You need a surface plate, and then you need a building up of slip gauges by ringing process. And then I've already explained this thing to you. And calculation is this, that whenever there is a simple case, when you have simple H and L, so H and L, H is your combination of your slip gauges, L is the length of your sine bar. And another is the case when you have a big object and then you need to measure this H1 and H2. So simple, using this formula, sine theta is equal to H upon L, theta is equal to sine inverse H upon L. For the second case, the difference in the height and length, you can easily calculate this angle. This is the calculation you can perform. Now I would like to show you one very interactive video website called whisk-online.com. Go to your Google or Chrome browser or your Mozilla browser and type this whisk-online.com. You will see this particular website. It's a very good website where you will find many mathematical and manufacturing or mechanical tools. In this particular search option, you just type Sine Bar. From here, you see this is using, there are two types of interactive tutorials. One is the Sine Bar and second is when you're using a Sine Bar. So I'm just taking this particular case.
Using a Sine Bar.
If you are able to see it, then we can proceed. I'm just playing this interactive tutorial. This is the website where you will find how to use a Sine Bar.
Learning activity, you'll be introduced to an inspection tool called the Sine Bar. With some simple math and the use of a dial indicator and gauge blocks, you can use the Sine Bar to accurately measure angles. A Sine Bar has two parallel cylinders an exact distance apart, usually 5 or 10 inches, and a plane along the top of the Sine Bar parallel to the center axes of the cylinders. Heat treatments harden Sine Bars to give wear resistance and a stable size over time, while grinding and lapping operations give Sine Bars their precise size. The buttons to see how the Sine Bar works.
So you can see here, it is asking me that add or remove gauge blocks. So gauge blocks, sometimes it is called slip gauges or gauge blocks. Basically, I'm adding some gauge blocks to it. I have pressed a single button for one time and it is added one simple slip gauges and it is showing a 5-degree angle. This is 10-degree angle. Then this is 15-degree angle. And then I'll press this next.
This looks suspiciously like right angle trigonometry, and it is. For example, if you wanted to lay out a 38-degree angle and knew the hypotenuse was 5 inches, you could figure out the opposite side using the following formula. Opposite side equals hypotenuse times sine of angle. Opposite side equals 5 inches times sine of 38 degrees. Opposite side equals 3.0783 inches. Also, notice the precision of this setup. The Sine Bar makes a perfect 5-inch hypotenuse. The gauge blocks, accurate lengthwise to millionths of an inch, on the opposite side and measure angles reliably to 30 seconds of an inch.
So basically telling all the measurements in the inches system. So here we are using the metric system, but they are telling us all the things in the inch system. No need to worry about it. You can also perform your calculation in your inches or you can perform your calculation in the metric. So that's not a problem. We are proceeding forward.
Angles on objects. Use the Sine Bar with an indicator. Using the correct gauge block set under one side of the Sine Bar causes the angle on the part to become a theoretically level surface. An indicator can then be moved across the surface of the angled part. The amount of variation observed on the face of the indicator corresponds to the accuracy of the angle on the part being inspected. Recommend that you use the Sine Bar for angles of 60 degrees or less. Some say 45 degrees or less, because the gauge block heights don't change enough to be accurate at steeper angles.
So basically what it is telling that your Sine Bar is recommended to measure the angle less than 45 degree. There are two reasoning behind this thing. One is the error, more error which you observed by the stacking of more number of slip gauges. If you increase the angle, you have to add up more slip gauges and then you see the size, the height difference in the lower angle is considerably significantly high as compared to height difference at the higher angles more than 60 degree or 45 degree. So that will not give you a very accurate measurement.
There's only a 0.0760 inch difference in the opposite side heights of 90 degrees and 80 degrees compared to a 0.8419 inch difference in the opposite side heights of 20 and 10 degrees.
So you see that how much the height difference is observed at very high angles and comparatively to this height difference in the lower angles. So if you like the video, then please subscribe to my channel, share it with your friends, and don't forget to hit the bell icon for the latest updates. Thanks for watching my videos.